In this video, we illustrate some of the basic topics of protection, using the industrial network example. With study case 2 activated, we see that the network variation, protection devices, is active. This introduces a number of relays and other related objects into the network model. The network diagram has been colored to show the locations of the protection equipment. Let us look at one relay in detail. Here we can see the blocks in the relay. To see how they are connected, we can look at the block diagram for the relay. The current transformer measures the current, and sends the information to the measurement block, which determines the maximum current value and the current for faults to ground, and sends these values to 4 overcurrent blocks. If any of these sees a current that is higher than the specified pickup current, it will send this information to the logic block, which will then send a tripping signal to the circuit breaker, if any of its inputs is true. Let us create a time over current plot for this relay. The time over current plot is in 2 parts, each representing one active block of the relay. If the current seen by this instantaneous block is higher than 2320 amps, a tripping signal will be sent to the logic block after 35 milliseconds. The second overcurrent relay block is set to generate a tripping signal for any current higher than 320 amps. Let us run a load flow calculation. The new line on the diagram represents the current seen by the relay. We can see that it is below the curve, and so the relay will not operate. Now let us run a short circuit calculation for a 3-phase fault at the connection point of the asynchronous machine. We can see that for this fault, the relay will trip instantaneously. On time over current plots, it is possible to represent not only the characteristics of protection devices but also the characteristics of the protected elements. Let us add the characteristic of the asynchronous machine. As you can see, in this case there is a starting current that is approximately 6 times higher than the nominal current. This has to be taken into account when selecting relay settings. Let us check the selectivity of this relay with the one above, by adding that relay to the same time over current plot. For the same 3-phase short circuit, the primary relay, shown in red, will trip in 0.035 seconds, and the one above, shown in blue, in 0.155 seconds. This means that the blue one will act as a backup if the red one fails to trip. If a number of protection devices are to be taken into consideration, we can do this by creating a coordination path. The first element is selected, then with Ctrl and Shift held down, the last element, to indicate the end of the required path. Now, if we click on Show Time Over Current Plot, at this point the shortest path between the 2 elements will automatically be created. The time over current characteristics for all the devices are displayed, together with a diagram on the left-hand side. The diagram can be edited if required. The short circuit calculation can be run again and the device coordination assessed from the time over current plot. To assess the whole network like this could be very time-consuming. A more efficient method is to use the protection ordered function. The grid, or part of the network to be audited, is selected, and short-circuit calculations at 10% intervals along the lines will be carried out. The required short-circuit definitions have already been added. The calculation is executed. Once the calculation is complete, the report can be run. We have selected Verify Device Coordination, which will compare the time delays between neighboring protection devices with the specified coordination margin. The report has a column for each short-circuit fault type, and these can be expanded separately. Then the results for a particular protected element can be shown in detail. We see that in this case, the secondary relay is tripping only 0.235 seconds after the primary, which is less than the specified margin of 0.25 seconds. Let us show a time over current plot for these relays. We can see the gap of 0.235 seconds between these two curves. If we increase the time setting on this relay a little, the time delay between the two relays will be increased above the threshold of 0.25 seconds. The audit is run again. Looking at the report, we can see that this particular problem has now been resolved.